Hi, I'm Ned and I make games. This video is from my live stream over on twitch.tv/NedMakesGames, where I'm live Monday, Wednesday, and Friday at 9 p.m. US Eastern Time. I'd love to see you there. Alright, hey everybody. Switch over. How are you all doing today? Hope you all had a great weekend. Mine was actually pretty good. I got to have some time off, so not always the case, it seems like, but anyways, let's get right to it. Today I'm going to, well, basically I've been working on a new grass video for quite some time, but the only problem is I can really only work on it on my time off, so it's been a little bit slow going. But today I want to try out a new method that I've been looking into where you can actually like spawn grass blades based on like what the camera can see. So I know it doesn't look like much right now, but you can see each of these are dynamically placed by having this soil camera render this red cube. So if I put both, okay, so it doesn't like this because the scene camera kind of messes up the buffer. But yeah, you can see that when you move the camera, or I guess the camera doesn't help so much, when you move this block, the grass also moves in the world. So basically this grass camera renders grass or places grass wherever it sees something. So it's a kind of cool technique. It should be able to work with just about any type of terrain as long as you can get it to render through this camera. But yeah, obviously there's still some glitches. Although it only does that really in the scene view. Although, okay, that's just making me a liar right now. Not sure why those other grass blades are kind of flickering. Because when I was testing this out last night, that didn't happen, but there is some strangeness in the Unity editor, I think, because like sometimes it thinks that the scene view camera is also trying to render grass, and I think that kind of messes up the soil placement buffer. So like one thing I've been trying to do is let me see here. So this feature like resets a buffer, and then this the soil camera sees this soil textured material, and then the material itself actually like adds grass to a buffer instead of like, so it technically does output a texture, but we don't actually do anything with the texture. And I've kind of been trying to do that so I can cut out the middleman of having a compute shader that will read the texture and then spawn grass from that. Because I think it'll be faster if I don't have to have that compute shader. But I keep running into strange issues like what you just saw. So I'm not sure if this technique is actually like viable for Unity. But I mean, if it doesn't work, we'll just output the data into this texture, and then we'll have a compute shader that will look at the texture and then spawn grass as we want it to. So yeah, if this doesn't work, we do have a backup. But the nice thing about this is like I said, I can create 2 of these blocks. And now grass will spawn on top of each. Although, let's see, there's the other block down there. And then you can change the density of the grass by increasing the size of the camera's texture. I'm getting good, pretty good performance. Though we can see from the frame debuffer that, okay, so this is the grass sprout camera, and it's drawing our 2 grass anchor blocks. Oh yeah, I can see the texture down in this corner down here. It's really small. And then the actual grass, or the final camera, takes the data and then creates these grass cards from them, kind of like we did for that flower project I was doing a couple weeks ago. Show the actual, so the grass blades shader. So it takes a grass point and then it kind of extrudes a vertex around it, and it does wind and everything. But yeah, so the only thing, it seems like these it's strange because like it seems like sometimes this is what I was looking for. So whenever we add something to the grass sprouts buffer, first we put a data object on it, and then we have to increase the number of indices by 6, which just means we're adding 2 more triangles. So that count should be enough to make these not appear, but they still do. So that's why, like, I wonder if that's due to this running, because technically a fragment runs like more than once per pixel because it has to do like anti-aliasing, but I have that turned off on the soil camera. But anyway, but yeah, so I don't really know why these sometimes just pop up in the middle. So yeah, that's really the only question. I'm not sure if this technique will work completely, or if I'm gonna have to switch doing that other way with the compute shader, which won't really be that big of a deal. But if we can you know, avoid the compute shader middleman, we might as well. Oh, so this is funny. I think that the game is looking through the soil camera. That's another thing we might want to fix. So yeah, I don't know. It's an interesting thing, but it just seems like there's a lot of strange bugs, so. But anyway, so let's go ahead. Like I said, we can keep on moving, and eventually we'll be able to just, what am I trying to say? Like, if this technique doesn't end up working out, we can just put the compute shader in between them. So I think what I want to do now is try to fix some other things with the camera. Like, you might have noticed, let's go ahead and make like one big flat piece of ground. Let's see how that looks. Oh, right, the soil camera's turned off. Okay, so now this is happening, I think, because the buffer size is too small. So we can fix that by... Let's, before I do that, let's move this camera so we can kind of get a better look. Okay, so now we can see a little better. So since it's flickering like this, I think it's because this happens whenever you see something like this, it's usually because your buffer is too small. And what happens is you don't know like what order each fragment gets computed in on the GPU. So it's like every frame it kind of switches between which ones get to fill the buffer first. So to fix that, I can just go to the Sprout renderer and increase this buffer size. Okay, so there we go. Now we have some. Okay. And yeah, it's funny, like whenever I move it, these other ones just appear in the middle. Oh. But that's kind of funny. It doesn't happen if I move the camera. It only happens if I move the, like one of the soil objects. So I don't know. I need to figure out why that's happening, but I'm not going to worry about it right now, I think. So another, okay, so this is another thing that I don't think is going to work. I just noticed that, see, the grass even appears underneath this other block, and that's because I guess Unity hasn't Z-sorted these textures or these objects before rendering them. So it draws the whole first thing and then puts grass on all of them and then draws this other one on top, even though it should be occluding the grass below. So, okay. That kind of puts the nail in the coffin of this experiment, I think, because yeah, we don't want grass to appear beneath this anchor for sure. Okay, we still can't see that well, but yeah, it's definitely above it. Let's see if I... No, I need to put them back. Yeah, okay. So, yeah, it's not being occluded by the crate above it. Yeah, even when I move this down below, it doesn't either. Which is that because there's no depth buffer or something? That could be because I might have turned it off when I created the render texture. Okay, so I did put the depth buffer bits. So that could be why. Okay, it seems not. Yeah, I just think there's too many like issues with this. Because we don't know exactly like how Unity's going to choose to render the texture. And this is kind of like a not super supported method. So yeah, maybe I'm trying to be a little bit too fancy here. Well, I mean, you can... Why don't we go ahead and try to do the compute shader method and see if that fixes these bugs. And I can always, like if it's a super big slowdown, then I'll have to get this method to work, but I don't think it should be that bad. It's going to be a little bit slower. Let's go ahead and see. Kind of hard to tell because the frame rate is still really high, but it's hovering around 700. Okay, so if it like dips down a whole lot, then yeah, we might have to try another technique. I'm hoping that, yeah, this technique has actually been used in games before. Not like, not specifically writing directly from a fragment shader, but using a camera to place grass has been used. But, and I kind of want to do it for my video because I think that it will work for a wide variety of different projects. So it's kind of ideal for a tutorial. But if it's too slow, then I don't know, we might have to try another technique. Anyway, so let's try to make a compute shader that will read the output texture from this camera and then spawn grass sprouts. Okay. Let's make another folder for compute shaders. I guess I'll say grass soil analyzer. Okay, so the main function, and we can have a lot more. Okay, so this is actually going to be a texture, so we can use the 2D ID here. Let's do 128 by 128 and start with that. Hi NTT, how are you doing tonight? Okay, so doesn't have to be a read-write texture. We could just do texture 2D. Oh yeah, so actually, yeah, we shouldn't even use this because this might not work for all different graphics types. Okay, so we have this problem. The other one, I think it's when we have to read a texture from a compute shader, we have to get I think it's the common library in the core render pipeline. I'm pretty good tonight. Thanks for asking. What's the inspiration for this new technique? I read about, well, I was trying to find a good way to create some grass or position grass for my next tutorial that I've been working on for a while. And I liked this technique because it'll work for a wide variety of projects, I think, because all they have to do is set up shaders that the soil camera can read. But I'm having, yeah, this technique I've been using that I sprout grass directly from the camera's fragment shader doesn't work too well because there's this flickering right there, and also it seems like this grass soil block doesn't occlude the block beneath it for the soil camera. So it's like rendering grass below it. So now I'm going to insert kind of like a compute shader middleman that will read the texture output from that camera and create grass from that instead of doing it directly from the shader, the graphic shader, if that makes sense. Okay, so this is what I was looking for. So the core render pipeline common file should have what we need for a texture. And then we can just define a texture 2D. Call it soil texture. And then we'll have the sampler. Okay, and so we need to get also the size of this texture, but I don't think we can use the texel size thing. I don't know if it'll get automatically assigned to a compute shader, but I guess we can try it. So yeah, in a graphic shader, if you ever need to get the size of a texture in pixels, you can use this kind of, I guess, trick. I don't think it's actually ever documented anywhere, but you basically just put the texture and then this underscore texel size suffix, and Unity will automatically fill that with values. I think the X and Y is the texture size, and then Z and W is the size of 1 pixel in UV units. So it's a neat little trick, but like I said, I don't know if it happens automatically for compute shaders, but we can fill out this if we need to. So I just kind of want to move this. Okay, so we kind of need to figure out what kind of data that we need to store in the texture so that this compute shader can kind of reconstruct this entire thing. So we can reconstruct the dimensions from the world position, sorry. So what I kind of need, so we need the normal. Oh yeah, I was testing something there. But we need the normal, and then also we need the data that it pulls out from this data texture, which basically tells it the... Okay, we don't actually use it because I was testing things out, but kind of it tells us like the probability that a grass blade will spawn on that position. And there's going to be some other things as well. Maybe it'd be... I was going to say maybe it'd be best if we just output like a UV, but then we couldn't have multiple textures for each separate soil object. But we're kind of limited on the number of things we can store in the texture. Well, I mean, technically you can output to 2 textures from a camera, but I'm not sure. I've never done that in URP because they don't really support it natively. Let's see. Okay, well, for now we can store the normal and this random value. And then if we end up having to go this route with a compute shader, we can again see how to output multiple textures. It's kind of a shame. I wish this method would work. It would just be a lot simpler, but oh, okay. I was trying to do too many threads at once. And here, so it has to be 1024 maximum. So let's do 64, 64. Oh, yeah, that's still too much. Okay, there we go. It's off by order of magnitude there. But yeah, I don't think, unless did I do something to turn off? Because I'm surprised that this isn't like occluding the grass below it, and I thought that Unity would know because it would do a depth test first. I don't think I turned off depth testing. Yeah, because it's on the opaque. Yeah, I didn't turn off any depth. And then the soil camera. Look here. It has a depth buffer. So, I don't know. Can't think of any reason why it wouldn't be rendering depth. Okay, so it's doing... So it does do a Z test and Z right, so it definitely is testing depth, I guess. So it's doing this one first, grass anchor 1, which I think is the smaller one. Yeah, and then... So, I mean, that definitely should occlude over this. So I would think that... So dynamic batching is turned off or is disabled. Okay. To avoid Z fighting. Well, that's not it. Because I would think that it wouldn't draw the pixels of the second grass anchor that were beneath the smaller one. And since it didn't draw them, then it also wouldn't draw... Yeah, since it wasn't drawing them, then this fragment function wouldn't even be invoked, and so it wouldn't make a sprout for the positions underneath, but obviously it still is. Oh, you know what? I think the reason why sometimes those we see like random points in the buffer, maybe it's because it's drawing a skybox. Well, actually, the skybox doesn't use a soiled shader, so that shouldn't matter, but yeah, we don't need to have skybox rendering on in here, so I can just set this to uninitialized. Although I guess now for the compute shader we will need to do a solid color, but oh. Okay, well turning off the skybox made it even worse. That's funny. But yeah, see, this is another issue. I don't know where these mystery... I think it has something to do with the editor because it only happens when I move an object in the editor. But I don't know for sure where those are coming from. And that's another thing that doing this compute shader method would get rid of. So anyway. Okay, so let's just try it out. I've talked about it enough. Okay, so we get rid of this, and we just need to pass the normal. And then this. We'll just pass the red component for now. Yeah, I know, like I said, I know we're gonna need to put more in here, but okay, so on here, first we need to reconstruct the world position. I guess first I need to make sure that this isn't larger than the than the size of the texture. Oh, is this the right semantic actually? I think it is. So first, if id dot x is greater than soil texture texel size dot x, which means this is larger than this texture, or id dot y is greater than or equal to the texel size dot y. So in either of those cases we can return. Okay, so first I guess we can read this texture. So this float for soil sample equals sample texture 2D. I think actually they have this load texture 2D that I can use instead of sample, I think. That way I don't have to worry about bitmaps. Okay, and so now we need to change this into a UV, and to do that, soil UV equals id.xy times the texel size ZW, because those have the size of 1 pixel in UV units. I want to make sure that's the right macro. Well, they have the X at the end for dealing with VR, but I don't have to worry about that. Okay, so now we can get the normal from this, which is soil sample.xyz, and then the spawn chance W. Okay, so now I need the I need to reconstruct the world position from this. So we need to get kind of the bounds of the camera. So I'll just call this soil camera rectangle. Okay, so what I will do for this, basically we can think about this rectangle as kind of being a texture, so we can use the UV to interpolate between the values. So let's see. Oh, I don't have the... Oh yeah, we're gonna need the depth here. Yeah, because we gotta reconstruct the Y component from the depth. Okay, so... Alright, so I guess we already can't use this spawn chance for now. Okay, let's try that, I guess. And I'll just make this depth linear, although I'm gonna have to figure out how to encode that in this value. I guess we could... Yeah, we don't need to worry about the depth. We can just pass the actual Y component, can't we? Yeah, we don't have to do depth. This will be... Yeah, okay, so that makes things a little easier there. Technically, we could just store the entire position, but we don't really need to do that, so... And right now, we don't have enough components in the texture. Okay, so now that we have that, we can get... So float to position... I'll just call it UV. Is id.xy, and I want it to be in the middle of each pixel, so we'll add half a texel size, or yeah, half a texel. So add 1/2, and then it'll be times the texel size again. And so then we can get the position, world space equals flip 3 soil camera rect dot x plus camera rect dot z times position uv dot x, and then the y, and then we can do the same thing for the z component. Okay, so now that we have that, let's just sprout a really simple, right here, I was looking right at it. Should be able to do this entire thing. In fact, why don't I just copy the function. Oh no, now we need the tangent. Well, we can just make... Okay, the tangent has to be orthogonal to the normal. I was going to say we could just have the tangent always point in the same direction. How do they... See, this is beginning to be a lot like deferred rendering. I'm trying to remember... Okay, so what they do in deferred rendering is I think they store the normal in view space. Or they might even... Yeah, I guess they store it in view space, and that way you can transform it to world space. Because, but that would still... We'd still need a tangent, wouldn't we? It's starting to be a lot of data to store. Okay, let's see. Unity, deferred rendering. Like, they haven't done deferred rendering in URP, and that's kind of what we're trying to do. So they have... Okay, so it's... I'm just trying to figure out how to output multiple cameras in or multiple textures in URP. But I don't... It's definitely not in 2020.3. I guess we could, if it is in Unity, I could just create a 2021. Let's see, what do they... Oh, okay, so it's not actually out yet. Okay, so we know that. Point light shadows. So 2021.2 has a bunch of stuff. Oh, okay, so deferred render is in 2021.2. apparently. I haven't downloaded that version yet, so... Forward plus render? Oh gosh, another thing I hadn't heard about this yet. So improves upon regular forward rendering by culling lights spatially rather than per object. This would significantly increase the overall number of lights that can be utilized. Okay, well that's kind of cool, but it's another thing we're gonna have to write shaders for. Anyway, okay, I wasn't expecting to have to go into all this tonight, so I'm not super prepared, but should I? Subscript. Oh, right. That should be normal world space. Well, at least that kind of works. Too many arguments. Oh, does it not need sampler? Okay, well that makes sense. Because it's just loading it directly, or the pixel. Grass sprout. Oh yeah, I didn't move over the structure. Yeah, I don't know. Is it? It might be possible to just have a texture with this structure. I guess I could also just, well, that brings back the same issue. I don't really want, I can't use this buffer. Cause I was gonna say I could just like have a 2D buffer. But I don't think the fragment shader knows what pixel it's writing for. So we couldn't position it in here very easily. Although I guess that would be technically possible because we could reconstruct the position based off the UV or the screen space position. What would be the best way? I mean, it'd be nice if we could just use a texture of this structure type so that I don't have to deal with multiple textures. Because like I haven't really worked in deferred rendering for quite a bit because it hasn't been in URP, but when I last did it in the built-in render pipeline, you had like a texture for color, a texture for normal, a texture for, what else was there? A specular lighting. And they were all there. Like it was for the entire screen. Each texture filled the entire screen, and then like a lighting shader would then like do basically a computed lighting and a post-processing effect by reading all those textures. So it'd be doing something kind of similar, but it'd be nice, like I said, if I could just have one structure that stores this, or one texture that stores this structure. But let me Unity texture with arbitrary structure. Does URP now support deferred? It seems like it does in 2020.2 or 2021.2, but I haven't tried it yet. Yeah, I don't think this is gonna work. Let's see. Unity camera output to multiple textures. Start video. Oh, well, I feel like I'm kind of at a... I'm not really sure where to move on from here. So I think let's pivot over to a different project. I'm kind of annoyed because I need to get this project done, but I'm gonna have to do some more thinking, I think, and so it's not the best thing to, the most fun thing to do on stream. So let's move over to something that I kind of know a bit more what I want to do. Okay, I guess let's do our falling petals from Friday. So this was basically a custom particle effect where I'm going to have multiple petals falling from the sky, and then I want them to collide with the world using the depth texture. And so basically we'll have a petal that will fall down, and then when it sees it's on the ground, it will stop there for a little bit, and eventually it'll despawn and then appear back up in the sky, and that will repeat. So right now we've kind of got it working, although it doesn't seem like it's colliding at the right time. So something with the depth is not working perfectly. Oh, speaking about this, yeah, my last stream we had that weird bug. It's actually, yeah, they're spawning really high up. I think that's higher than I had wanted, so that's another thing to look at. But there was that weird bug last time where Unity would just stop compiling shaders, and it had to do, I did some research after the stream, and it had to do with the compiler basically removing an element of a structure that wasn't used, and then it would like mess up the buffer strides, and Unity just was like, didn't know what to do about that. And I think it's because I don't use this fade value in this shader, so the compiler thinks it's being helpful by removing it from the structure, but since all the strides account for this fade, it makes Unity throw a fit basically. So the easiest way to get rid of that, I think, is kind of pretend like we're using it. So we'll just make a new petal. So let's see. This will be, what do I want to call this? Let's make another one. So petal, new petal equals petal 0, and then this new petal, we can set the position, world space to basically the 3 petal position world space dot x, and then we'll take the max of these. And then we can just pass the other two components through, because the compute shader is not going to mess with them right now. It's just basically the initialization from before. Didn't I can spell it right. So I think, well, I'm hoping that by passing them through to this new structure, the compiler won't try to like get rid of it. Oops. That should just be. Okay, and then we can set this to the new petal. I just realized I spelled this wrong a bunch of times. Okay, and yeah, so we don't set that there actually. Okay, so let's hope that structures defined for numeric base types. Oh, I did this backwards. It should go like the pedal should be in the parentheses because we're casting 0, which is basically just fills all these values with 0. Oh no, is it messing up again? So what happens is when it does this, the baking shaders doesn't respond. So I'm just going to restart it one more time. If I'm wrong and this doesn't fix it, then I might just remove the fade value. And if that doesn't fix it, we'll move on to another project because I don't want to deal with this. But it's really weird because like it doesn't, nothing happens like when you start the game and it's still like it's compiled the compute shader. For some reason it only happens like if you change it when Unity's still running. So I can look in here. It's kind of, I was gonna say it's kind of hard to see if it's actually changed anything. I'm trying to see if I can notice that it's, I think it still might have taken those values out because it doesn't like set them. But maybe it does in one of these other, because like technically these like add values and then also store them in the first register. Okay. But so we're good so far anyway. Okay, so to try and find this bug, it seems like it's colliding too soon, and then also the pedals are like respawning too high. So that tells me, since we don't actually set the pedal except to the maximum of these two, it feels like this collision position gets super high in the sky for some time. I wonder, I was gonna say, do the pedals right to the depth and that causes an issue, but I don't think that the pedals do. I guess I should say, okay, well they are opaque, so I guess I should turn Z writing off. I don't really know if this would cause any issues, but okay, so that's not it. Oh. Okay, well something changed because they just all disappeared now. Oh, okay, it must be something to do with Z write being off. So if it's off, they won't write, or they won't draw against the skybox. But yeah, I think the same problem is happening, so that didn't fix it. But yeah, it is funny because it's not like, because we don't like say that like if the depth gets to a certain point then set higher. It just, because what I was thinking would happen is it would get to the collision point and then just stop, but instead it like pops up higher. So what could be causing that? Because we just used the world space position and then we read depth. trying to think of a good way to test this. Instead of changing the Y position, maybe I can just store the depth in this fade value and see, and then we can kind of see what happens. Yeah, I'm not sure how well that will actually help, but I guess I could also just set the position to the collision position. I think that would be kind of strange, but let's see what happens. Oh, it's doing it again. Okay, so yeah, my little trick did not work. Okay, so let's... This is a really annoying bug. And the thing is that somebody reported this to Unity, and Unity marked it as will not fix, because they said you can just remove things from structures. Which is true, but I think if I remove... Because like technically the tangent to world isn't used by this compute shader either. And I think if I remove it, then Unity will... Like, because obviously we still need this. Let me see something. I was gonna see if I could see like the size of the buffer. Or I saw like the stride of the buffer to see if it is stripping stuff, but I don't see. Unless this is it right here, 52. What am I trying to do? Oh, I was looking for the compute shader, but I got knocked off. Let's see. So if I just test it, if I test this out and remove those two, well, oh, I got rid of it. It was like 52 before, I think. I want to see if that number changes, which means that, okay, so this is the stride. So that's kind of good to know. So, okay, so technically, I guess it's not stripping those things out of the structure like I thought. Then, okay. It has something to do with like unused, unused fields and structures, because at least that's what the person that responded to that bug report said. Anyway. This is so annoying. Unity doesn't want me to do these streams lately, it seems like, but thanks everybody for putting up with all this stuff. But anyway, let's see. Okay, so right now they're set directly to the collision position. So yeah, we can't see them, which is kind of what I thought would happen. Because I think like it's colliding with the skybox, I think. So it's like setting it way back. You can all empathize. Yeah, I guess everybody has to deal with these kind of bugs lately. It's just a little bit more frustrating when you're trying to do something for other people to watch, but okay. So anyway, okay, so that's kind of interesting. It seems, you know what? I wonder if it's like, because it seemed like when I brought this up, it's making them collide sooner, which I guess makes sense. I wish that there was some way you could get the scene view not to interact with the rest of the game, because I had the same problem with that grass that I was doing earlier, because the scene cameras like interact with the rest of the system. But I don't know if that's causing these issues. Let me see. Oh yeah, so I'm gonna turn off the Z right off because it just makes it hard to tell what's going on. And I don't think that's the issue. Okay, good. And the shader compiler didn't crash. Okay, so now it's frozen. Oh, it's because of the shader compiler. Yeah, see, so when I do this on the, you can tell like the petals start to disappear when this object gets close to them, and I think it's because of the depth. But I guess that only happens when I go into the scene view, so that's not what's going on here. I feel, well, I'm still don't know why they tend to like pop upwards. I feel like they should just stick to the ground. What if I did? Okay, let's do something. Okay, so I'll just use fade since it's already here. I'll set the position, like we'll only deal with gravity until we collide, and then if like the collision position is higher than pedal position, we'll stop moving this pedal downwards. So that way we can see like the first frame it collides. That might be useful. Okay, so right here, like if pedal dot fade is greater than 0, then we'll return. Okay, so yeah, we'll do this once, and then you could probably do this more efficient, because I know shaders don't like branching, but I'm just gonna go with the obvious route for now. Okay, and then the shader compiler is gonna mess up. But now we are actually using the fade variable. I guess we're still not using tangent to world. Okay, so that's kind of interesting, because now we can see that once they get to a certain point, they collide, but then the collision position just like is randomly much higher than you would think. So I don't know why it jumps up like that. So maybe let's not do maximum and just see what happens this way, where we don't set the position to the collision position. Okay, so even here they don't really collide. It seems like, well, the depth isn't really consistent, but it does seem like, actually maybe all these started below. So it does seem like they first collide. Well, yeah, it's not completely consistent, but for some reason it's at a level above the actual. Okay, I was gonna say, I wonder if it's floating point inaccuracy, but the clipping plane is not that big, so let's like that a little bit so it's not like straight on. I don't think that should matter, but I'm just gonna wait until all the particles collide. Okay, and I think I'll spawn them up a little higher so we can see for sure what's going on. Okay. So I need this feature, because this is the thing that starts their position. So I can just set the world bounds position a little higher. Okay, so now, because I don't want it to ever start below the collision point, it seems like I need to still do higher. In fact, so this can speed up a little bit. I'll set them all to spawn at the same height. Okay, so now they all collide at the same position, which is kind of interesting. If I add a little bit of randomness back into it. Okay, so it's still pretty much the exact same position. So obviously, I think something is wrong with the code that we use to find the collision position. Well, I guess we kind of already knew that, but now we know that it's higher than it should be. But the thing is, I copied this code like from Unity, so let's see here. Oh yeah. So, oh, I should also change my stream info. I just realized I'm not doing the grass anymore. So let's see. Working on falling petal particles with compute shaders. So sorry if anybody came by expecting grass. We had to switch off that that project for now. Okay, so yeah, I was following this guide from Unity, and I pretty much copied the code. What's this? Yes, we got the depth. And then we take care of if it's reversed Z mode or not. Scaled screen parameters are actually automatically set. So I think the only thing that I did that's different than this is I couldn't use this built-in matrix because I don't think it was set for compute shaders, but maybe it is. Let's try it. Okay, because yeah, this Unity near clip value was set, or at least it didn't throw an error. Oh yeah, the projection matrix, that's what I was looking for. Okay, so I guess that part isn't here. So what am I doing there? So I'm trying to get the clip space from the world position. So this is basically transform world position to H clip. Which we can find in the space transforms function or file. Transform world to H clip. Oh yeah, so then we looked and saw get world to view matrix. Oh wait. Okay, so why don't I just call that function and see if it will work with a compute shader. Okay, the compiler's gonna scream at me again. Yeah, it doesn't seem like this bug is going to get fixed. So I need to find out exactly why that's happening. Okay, well at least nothing is complaining, so I guess those matrices are set. And yeah, it looks like it, although we're still having that bug. Although interestingly, now it's sloped in like that camera's view plane. Okay. Okay, well doing that didn't fix the bug. It's doing checkerboard. I think the rest of this code, yeah, it's just the position in clip space divided by the scaled screen parameters, which we're just using Unity's values. So all this is basically taken from this file, but it doesn't seem to work. Okay, I'm probably doing something wrong, but so the position can't be wrong here. Maybe do I just need to? Oh well, for one, I'm using the world to H clip direction. I don't know if that really matters, but I think it's the same function call. I guess I could just call this function in the compute shader. I don't have to do it myself. So it's saying implicit truncation. Oh, yeah. I wonder if that could have been the problem, because yeah, I forgot clip space. Well, I guess I just didn't think about it. Clip space actually has 4 components because it's what they call a uniform. Yeah, I think a uniform space. I don't think that's the right term, but it has, because like if you're going to actually work with it, you have to excuse me, you have to divide the x, y, and z components by the w component, and that's how perspective works. I don't think we have to deal with that here. It doesn't say to do it anyway. So how does it get Yeah, it doesn't normalize it. Okay, so I won't. That could have been our issue. That was kind of a silly mistake on my part, but okay, so let's see how it works now. Okay, well no, that wasn't it, unfortunately. It's still colliding at a bit of a like it's following the camera's plane, which is kind of strange. Okay, so nothing will happen if I do this now because we set it to not change anymore after it collides the first time. But I wonder, like, if I do this, will it start to collide at this angle? Okay, well, they definitely go lower, but yeah, it's still just on like the camera's plane. Although it starts to kind of curve up, so it's almost like it hits it. With the frame buffer or the frame debugger, can I see the depth texture? Copy depth. Yeah. It's kind of hard to see because it's like, you can see a little bit of red here, but everything else is so dark. Maybe let's put another object here and see if that affects things. Okay, and see if this depth affects anything. No, it's so weird. It just like follows the camera's angle. What am I doing here? So we transform position to clip space, which is again like kind of like screen position, except it goes from -1 to +1, and then it can sometimes be reversed. And then we get the screen UV by just taking the X and Y components multiplied by the scaled screen parameters. So let's look what that is specifically. Oh. Okay, that doesn't show me where it's defined. This just defines everything that's, it just tells me everything that's there, but doesn't say what's inside of it. So this must be another like hidden shader variable, but they don't actually tell you what's in it. Okay, so here, the fragment shader to calculate UV coordinates, sampling the depth buffer, divide the pixel location by the render target resolution. Scale, oh yeah. Okay, okay, so this is actually, don't we use this in another project? Yeah, so this is the resolution of the render texture for the camera. Okay, and then the fragment shader, we use sample scene depth to sample a depth buffer. Copied this word for word. Unless some of the stuff works different. Okay, so let's look at this function. Maybe this will tell us what we need to know. said it's in the common.hlsl file of the SRP core. Okay, well, it's not. So we know it exists, and oh, okay. I was gonna say, yeah, we only include this file, but I'm sure it includes some other things. So yeah, it includes the universal core file, which includes a bunch of other things. So the common packing version input. But I guess we can start here. So nothing in here. I think it also includes some other stuff at the bottom, but shader, variable functions. Let's check that out. Oops. Okay, so yeah, here it has scaled screen parameters. This might have what we need. Compute screen position. Fog. Okay, I wonder if we need to use one of these to get the clip space position actually. So get normalized screen space UV. This doesn't have the file we need, but there is some interesting stuff there. Yeah, because obviously something's not right in that tutorial unless I'm doing something wrong, so we're gonna have to figure out what it is. Okay, so does this include any files? Okay, well, it does, but just the stuff for the different APIs. Common deprecated, no. We already looked in there. So, and this doesn't have the function? Oh, I don't know. I guess I copied something wrong. Compute world space position. Okay, so position clip space, inverse view production matrix. Okay. Let's clean this up a little bit. So we're calling this one, so it needs position normalized device coordinates, which I think is green space. So then it computes clip space position. Okay, so basically it just computes clip space position and then calls this function, which is the same thing. Okay, here's normalized device coordinates. What is this position? Oh, I see. So you use it for different types of matrices. So if we have clip space, so maybe we need to, because this wants normalized device coordinates, so maybe we need to compute that from the clip space position first. Try it anyway, instead of using the screen UV. Could be the same thing, I don't know. I guess we can look at this function too. Okay. The Z value is the depth buffer value, not linear, blah, blah, blah. So it does do some stuff. Okay, well, let's try this. This is a good lead. Okay, so then we pass it the position in clip space and let's see. Okay, well, it's gonna implicit truncation because that returns a float 2. Which, yeah, this is float 2 in device depth, so that... Okay, but it takes a float 3 position. So I wonder if we need to normalize the clip space before we do this. Well, let's just try this, and if I need to, I can divide it by W. Of course. I'm so tired of this compiler crash. Okay, so let's see if this works. Yeah, it's telling me there's a okay. Okay, well now it's saying that they collided already up there, so yeah, that something is wrong. Let's just try normalizing this and see if it works. Okay. Nope. Still messed up. Although I was gonna say progress, but what's the deal? Because I thought that maybe these were colliding with this higher bit, but I don't know why this one is sticking out, and then why are all these, why all they collide above it? Okay, so it's pretty consistent. Okay. Not that. Let's see, so compute world space is a utility function that calculates the world space position from the UV and the depth values. This function is defined in common HLSL. It's the inverse view projection matrix, which we're just using the one Unity has provided us, so that's got to be right. Okay, maybe we just need to make something like this that creates these checkerboards so we can make sure this is all working. Okay, so let's just do a screen space shader. And yeah, we can figure out what's going on. I'm just gonna copy and paste this. So depth, checkerboard. And I'll copy and paste the HLSL file so I don't have to do all the boilerplate. I guess we'll need like a width and stuff, but I'll deal with that later. Okay, so yeah, we don't need culling because this is just going to be on a post-processing effect. Okay, so hopefully we'll be able to get this shader working correctly, and then we can port it back to the compute shader. Okay, so from the attributes function, or a structure, which is just what we get from the shader, or from the material, I think we'll just need the UV. And then the output, yeah, it'll just be a UV again. Although, actually... Okay, okay, let's actually do this as like a quad in the middle of space, so that way we can test converting from position a little easier. Position, world space. Okay, so here we'll just need position. Yeah, and I'll see. So for our falling petals, we only have the world space position, so I want to start with that. So we'll just pass that through. I guess we still do have to compute the clip space for the shader, but we just won't use this in our calculation. So here, just do pretty simple. So get vertex position inputs position dot os. Oops. And it's input. Oh right, and I need to do attributes input. Okay, and here I'll just remove all this, and for now we can just copy this code. Okay, so we got the world space, and then we have scaled screen parameters, load depth, so this should all be fine. And from this collision position we can create our checkerboards, but I need to make sure that I have the declared depth texture file included. Actually, yeah, we don't need lighting actually, but okay, and that should have everything we need. Okay, so let's just copy the code from here for the checkerboard effect. I'm not sure why they're messing with the depth. Oh, they're saying, okay. Yeah, they're saying if the depth is the far clip plane, then they just return black, which makes sense. Okay, let's set the checkerboard scale. And if we wanted to, we could do 2 different colors. I mean, why not? Flip for checkerboard color A and checkerboard color B. Okay, so what is this doing? I guess it doesn't really matter, but this will be checkerboard scale. So it's snapping these to integers, unsigned integers, and world position. And then from that, it's dividing the surface into squares using... Okay, so it's saying if... Okay, it's basically checking if any of these are odd. Because it's seeing if they have... It's kind of a confusing way to do this, but it's using a bitwise AND operator on the integer version of the x coordinate. So if the last bit is 1, which means it's odd, or the y component is odd, or the z component is odd, and then these are the bitwise exclusive or... Okay, so it's saying like if only one of them is odd, which makes... Yeah, so that would be the checkerboard. Because the exclusive OR is when one or the other is true. Or only one of them is true. And then when you do it 3 times, it can get a bit more confusing, but I think due to order of operations, it would execute this first, and then this. But anyway. And then here it's just saying if it's the white color, then we'll choose our color A and color B. And then here it's saying if the depth is the far plane, then just return black. But we have to, if it's reverse Z, then the far plane is 0. If it's not reverse Z, then the far plane is 1. So let's see if we get any errors from that. I guess I should... Okay, well, yeah, the compiler is messing up again. Alright. I think there was a bug, but it could... Yeah, a bug, but it could have been because of the compiler. Okay, so what is something? Get vertex position inputs. Oh, okay. I need to change this to be position object space, not world space. And then cannot complicitly convert from float 2 to float 3. Oh, right. This returns a structure with a bunch of stuff, so I just have to get the actual field out of it. That was wrong. Cannot implicitly convert from float 2 to float 3. Get vertex position inputs. Oh, yeah, this should be a float 3. Okay, undeclared world position. Oh, that's just because I changed the name of it. So, input dot position world space. Technically, that's not needed. Okay, so now are we done it? First I thought we'd have to do like a full screen rectangle, but we can actually just make a plane. Let's scale it up. And when we apply the shader to this thing, it should color everything behind it based on the depth. At least that's the idea. Let's make a material test depth checkerboard. Oh, right, and then I need to add the properties to the shader. I don't have to say that. It's not depth either, it's scale. Float type, and it was pin. Now we need to do both of the colors. Let's do red and blue, I guess. Okay. And if we apply it, okay, so, okay, well, we can kind of see that things are not right, but they're kind of right. Because if you can see the shape, but it's all distorted. Oh, but it could be because I'm in the scene view. So I put it in the game view. Okay, but it's still not correct here either. And I did. Yeah, I turned on the depth texture. Depth texture, use pipeline settings. If I turn it on, it doesn't do anything. Okay, so now we know it's not working. Oops. Which, yeah, we already knew, but... Although, yeah, not only is the checkerboard not actually reflecting what's behind it, the checkers are all distorted. Although, yeah, one thing I did mess up here is that we shouldn't... Yeah, we should be using the collision position. If that's the case, I don't know. That other effect was kind of strange because we were just using the input world space. So now I'm wondering if this checkerboard code doesn't work, but... what is going on? Okay, when you turn the scale up, you start to see a shape of something, but... Okay, well first let's try to make sure that this checkerboard code works. So we'll just get the world space position. And I'm just gonna make sure that's all it depends on. Because yeah, it doesn't... So yeah, we don't actually use any of this stuff. Which makes what's happening here really strange. Because it shouldn't care about the camera at all. comment that out. Okay, well, it's still using the depth, but only down here. Okay, I guess that was making the shape, so. But yeah, still. Checkerboard is not the most regular. If I turn off rotation, it still messes up around 0. Although besides that, it works. Okay, well, I guess this is fine. Let's just, yeah, we don't have to really have angles. I feel like it doesn't. Yeah, the reason that happens is because it's an unsigned integer, but I feel like we don't actually have to be unsigned. Okay, well, that doesn't fix it either, but. Oh, it's because like the having because it's the last bit that is the sign for an integer, isn't it? Oh, well, maybe I'm. Again, it's been a long day. Let's see. Anyway, let's leave it like this, I guess. So yeah, just there's this weird thing in the middle. I mean, you could, if I wanted to, you could fix it by offsetting around 0, but it's not super important. So anyway, let's turn back on the depth and see what it looks like, and just remember that it doesn't like to be angled. So that's one. Okay. Well, this isn't right, obviously, because it's turning black when it's supposed to be against the far plane, but it's not against the far plane. Okay, well, okay, that's another thing. This is still using the world space and not the computed depth. Okay, although, yeah, this looks very strange. Okay, I was going to try to set the scale to see if we can see any checkerboard-like pattern. There might be one, but it's extremely small. It almost looks like it's just because I'm zooming in and it goes really far. So it kind of stabilizes when you get super close. But there's these weird zigzags. Hmm. Oh, I wonder if that was causing an issue because this was a different. That was the normal integer and that was an unsigned integer. I doubt it, but. Well, this is annoying because I'm following their tutorial, but it's not working. So let's see. let's just try something different. Unity, compute, world position from depth. Kajiro is trusted source. Okay, so he has it in the lightweight render pipeline, which should work because that's just an older version of the sorry, the universal render pipeline. Okay, so far side or far clip plane. Yeah, far clip plane. That's what I was trying to think of. Okay, so what does this do? You got the position in whatever this is. Vertex ID to clip space vertex position. Okay. And then you got the text coordinate from that as well. And then he's made like array to array cast from, because this is like a full screen quad, I'm assuming. So okay, so here he's got sample texture, some stuff with the far plane. Oh, let's view space position, so that's not what we want. Visualize position. Okay, I don't think. Yeah, maybe this isn't what we need. Just detecting borders. This example, it shows how to inverse project depth samples into view world space in Unity. So it seems like what I need, but that doesn't, the code doesn't seem to match, but maybe I'm just misreading it. So he's putting it in view space, which we can pretty easily transform to world space. So if we could get it in view space, I'd be fine with that. So now he's got the Z buffer. So the rate multiplied by the depth. Oh yeah, because the Z buffer is in like logarithmic view, so he multiplies it with the depth. Okay, so I see. So he just uses our like a array to kind of raycast, but I need to do this in the fragment function because this will be like we won't do like a full screen quad for our flower blossom particles. Feels like we've listened to this song already tonight. Okay, so we have a projection camera, so we don't have to worry about this orthographic stuff. So it multiplies the camera inverse projection times the far plane. Perspective view space vertex position of the far plane. Okay, so it's kind of This ray is actually like the end point, and then the start point would be I guess 0, 0, 0 in view space. Okay. Well. Okay, so this is kind of how I was thinking we would do it. We'd get the camera position, and then from the depth, we can kind of interpolate between the far plane. Okay, so let's try that. Let's just get rid of all this code. I guess we'll stick with a checkerboard. Okay, so I guess we can keep all this. I'm just gonna delete all this code. Okay, so what we want to do is we need to find the position to the far clip plane. So what it does, it takes the vertex position and then in clip space, and then it converts it to view space. So could we, I mean, we could technically just, we could convert it all the way to world space, right? So float 3, far plane position world space is, let's look at the, so we need to go from clip to world space, which I think we saw a function like that, but transform object tangent, transform world object. Object to world, world to H clip. Oh, well, that was what we need, world to H clip, right? Because we start with world. Okay, well, this is actually, yeah, so we need to take the position on the far plane, which from that we, let me see. Okay, so we start with a position. So I guess we gotta transform our world position to clip space. Then we can take that and find the world space position of the far plane and then interpolate between them. So yeah, I feel like this is less efficient than that other version that Unity was using, because we're going to have to do more world space transforms, but obviously the other way didn't work, so or at least I was doing something wrong, I don't know. Let's see. So this is position clip space. Okay, so now we have the clip space position, so we need to change the depth of the clip space position to okay, so the far plane is projection params.z. Okay, I see what's going on. Okay, so I think what I have to do... wait. Yeah, so some of this math might be wrong. I'm just gonna try to work my way through it. Normalized is... So again, clip space is homogeneous, which just means we need to divide by W to get to normalize it. That's kind of how it does perspective. Actually, yeah, we can just divide the whole thing by W, and then I'll just have a 1 at the end, which works fine. And then we can just do what this code does. But I actually can just, I think I'd rather it just convert to world space. So yeah, I can use this inverse view projection to get from clip space to world space. And the far plane is that projection parameters dot z or whatever it was. Okay. All right, so now we have the position on the far plane. So theoretically, the collision position would just be an interpolation between the camera's position and this far plane position. Oh, not quite. It's actually an interpolation between the near clip plane and the far clip plane. Alright, this is starting. It's like 10:15 here. It's starting to be a bit too much math this late at night, but I'll try to get through it. I wish that there was some way I could like test this before I work anymore. Let me see. So I was trying to think, like, do we need to... Because if I put this in the world space, I need to get the camera's position in world space. So I was wondering if it's just possible if we just stay in like clip space and then convert that back to world space once we're done. But I don't have the camera's... I guess the camera's position in clip space is 0. Because yeah, if I work in world space, I'm going to have to get the position on this like angle from the camera on the near clip plane, which we don't really calculate right now. So okay, well, let's see. Let's to make this a little simpler, let's just work with the clip space position that we have right now. Although I'm gonna need to be able to like transform world to clip space, but this will just be like one less thing I have to worry about. So, and then once we got this working, I can try converting from world space back clip space and then back again. So I'm just going to do pretty much exactly what is in Keijiro's code here. Alright, so he computes the far clip position. What's going on? Okay, so I don't need this position. I was being confused for a second. So I actually need this, and he's like interpolating in case you have an orthographic camera, but we only are going to use perspective camera, so I don't have to worry about that. So anyway, so we multiply. So he's going from clip space to view space. But I wonder if I can just stay in clip space, because then I wouldn't need to like... Well, there's probably some reason why he's done it like this, but if I just stayed in clip space, then the near clip plane is at 0, and the far clip plane is at 1. Anyway, let's do, like I said, exactly what he's done, and then I can try to optimize it as I need. So I should have left this part. So load, depth, texture. You just got to pass it the UV, and then what does he give as the UV? Oh, so the text coordinate and this world space. He computes that here. So that's one thing I'm going to have to do different. Where was that? It's here, right? So I can... So this code is... It's in the universal render pipeline, so I don't know why that other thing didn't work. I just feel like I had to have done something wrong, because this is used in Unity's own stuff. So normalized device coordinates is basically the screen position. And we can compute normalized device coordinates. And the Z value is even a depth buffer value. So isn't that just what we need, basically? And then we would just pass X, Y, and Z. Okay, I know I'm changing gears again here, but I don't think Keijiro's code is really going to work for us, because it's just too different. We'd have to take too many risks anyway. Okay, so we have this, and it needs so world space, and then I can pass this Unity matrix VP, and it will give us green space with Z apparently. Although it doesn't like, I don't know, it doesn't read from the depth buffer, so I don't know for sure how that's gonna work, but... Okay, well I guess this is just giving the depth of this object. It's not actually reading from the depth buffer, but so input dot position world space. Okay, and yeah, it told us to pass that matrix to use world space because it's converting from world space to clip space because this is a view and projection matrix. And then I need float 3 position normalized device coordinate. Okay, and now the depth I can get from a load depth. I deleted that polygon. Load scene depth, and I can pass the position device coordinate XY. Hopefully, I hope this is correct. We might have to flip some values. And then, and so then we can compute view space position, passing this depth, and then the inverse projection matrix. Theoretically, anyway. So all right. Oh yeah, I guess we could just do that. It doesn't look right, but it's at least better than what we had before, I think. Yeah, I don't think it's actually giving us a depth because you can see it doesn't, well, these particles are kind of in the way, but it doesn't like affect the, or this pull in the middle isn't showing up. Go, turn off the particles for now. Like doing things like this should change the depth, but it doesn't. Okay. Okay, well, I guess let's make sure this is the right thing. I'm pretty sure the screen or the normalized device coordinates are the same thing as the screen UV, but I guess that doesn't really mean that it's the same thing as Unity's like depth texture. I don't think this is what we need. Okay, compute screen position. Yeah, we don't want to use that V pose because we won't have access to that on our shader. Let's just find out exactly what these are. I'm pretty sure, like I thought they were about the same as screen position, but it's not just clip space. Homogeneous clip space X and Y have negative W to W range for what's in view, but normalized clip space X and Y have a 0 to 1 range. They're essentially screen space UVs. That's what I thought. Homogeneous clip space by W just makes it non-homogeneous clip space. Yeah, which is not. Yeah, so yeah, normalized device coordinates is, yeah, the clip space divided by W times 1/2 plus 1/2, so. Okay. So this should be it, but that doesn't necessarily mean this is the same as how the depth texture I'm trying to say how the depth texture is stored in like its UVs. Okay, let's make a shader graph. That way maybe we can steal the way that Unity reads it from there. Or actually, let's just like output the depth texture and not worry about all this stuff. With the checkerboards for now and see how that looks. So depth. Oh yeah, I always do that. It should be flip 4. So it doesn't show anything right now. And it flickers when I do that, which is kind of weird. So it gets lighter when I get close to the camera, but it does that weird flickering thing. Oh, it's because I'm not playing. I bet that's why, because in the scene editor. What? Why is it? Okay, there we go. That was funny. It was like it was being invisible. So it gets brighter when we get closer to the camera. Oh, is this? Okay. I wonder if all these problems have been because this rectangle is also writing to the depth texture. So I need to turn that off. Okay, that's... Oh yeah, if it doesn't write to a depth texture, it won't show either. Let's put it to transparent. Or wait, I could just do opaque +1 so it'll run after and Z test off. Still not showing. Yeah, so I specifically put this in Q+1 so it would run after. But it's running before. Oh, maybe I need to turn Z-clip off. I always forget that there's Z-clip and Z-test. Okay, well, it was drawing in frame debugger, but not in the view. Is it like, do I have to put negative? I don't even know if that works. No, it's still rendering before. Oh, I'm changing the type, not the queue. Oh, that didn't do anything. Maybe the render queue doesn't work in URP. This works, will it work? Transparent stuff. It should run afterwards and it doesn't worry about the depth, which is what we want anyway. That wasn't what I wanted. Frame debugger. Okay, now why is that still there? Because I set it to transparent. I'm gonna disable that and see if this just makes it show up. Well, it does, but I think that's because it's still Unity wants it to be an opaque object, even though I marked it as transparent, but it's ignoring that for some reason. Yeah, so checkerboard, it's still in the opaque objects. Why is this not working? Trying to think of, let's make a transparent shader graph and look and see what it puts for its tags. Alright. And save. View generated shader. Okay, so render type transparent, Q transparent. Maybe it's because I didn't have a blend set, but I thought it would default to something. In fact, let's just copy this. Okay, thankfully it finally shows up. Let's look the frame debugger to see if it's in the right spot. Draw transparency. Okay, yeah, it's in here. I guess I just need to specify a blend node. I thought it would have done it. I thought it would have given me a default one. Okay, but fortunately that doesn't fix the problem. Well, maybe it does. If we change the depth to linear, maybe? Let's see, is there a function to do that? In URP? Oh, I have no idea where to begin looking. I kinda do, actually. Let's see. Shader, graph, scene, depth node. Usually this will tell you. Okay, well, it just gives me a macro, which if you look in the shader graph code, we might be able to find it. Functions, sample scene depth. Oh, yeah, this is trying to look up stuff in the shader graph is annoying because it has these like dummy functions that do nothing and then they get overwritten. You've got to try to find the code that overwrites them. Okay, so here, oh yeah, so the shader graph, if you've never looked in this code, it's all like generated code, so everything is like a string that it adds together. So this strength raw, strength linear. Okay, so that's what I want to do. I want to transform it into linear. So, okay, this linear Z depth with the Z buffer parameters should do the trick. I guess we can just copy it. There, I was looking for our HLSL file. Float. Okay, we already have the depth, so we don't have to sample it again. Okay, so okay, so this tells me either the scene or the dedication of problem solving is very inspiring. Oh, well, thank you, NTT. Sorry if you had said that a while ago. Yeah, kind of zoning into it, but yeah, this problem, if you get a bug like this, you just gotta keep on trying until you fix it. But I have to say, I kind of wanted a smoother stream today, but it's all right. I keep on picking difficult topics, so I guess it's kind of my fault. But anyway, so since this is all one color, that tells me either that the depth texture isn't like being generated correctly, or the coordinate isn't correct. So let's see, how can we make sure that the depth texture, I guess let's make I'll just do a shader graph. And we'll just basically do the same thing I've done here, but get the scene depth. We've got to do screen position. So this should work if the depth texture works. And material, depth, test, graph. Okay, and then if I apply it to the plane. Oh, I think it's because it's set as invisible or transparent. So I just, oh well, alpha is 1 actually. Oh, okay. We just turn on two-sided pulling. Okay, so the depth texture does work. This is what we want it to look like. Or wait, it worked in the scene. Okay, it does work here. So this is what we want to happen. So that tells me we must have like the coordinates that we're using to read the depth texture are not right. Because we're basically doing the same code. Normalize device coordinates. We don't need the Z, but when you compute it without the Z, it just throws the Z out, so it doesn't make any difference. Oh. Okay. So, I mean, this... We read that that was supposed to be screen UVs. But I guess we could try to find that compute screen position function. I have no idea where it is. I do know that it's not in the space transforms. Oh. Oh. I already did this, so... I don't remember looking that up earlier. Let's see. So maybe... I don't know what position is either. I would guess it's clip space position, but it doesn't actually say. Maybe I can find a more descriptive function. Oh yeah, so it is clip space. So I need to find out what file this comes from. Yeah, okay, that's okay, so it just comes from the shader graph. I don't know, that can't be right. I'm sure there's something in the library. At least we know you need the clip space position. Isn't it so fun to look through the URP library? Shader variable functions. It was basically... So it's basically the same thing, but that we already got. Okay, so it's the same place we get vertex position normals. Shader variable functions.hlsl. Let's clean this up a little bit. And so wait, so we don't... Well, I guess I still need this because this compute view space position wanted that normalized device coordinates. So, let's see. Float 2, screen, position, or I guess I could say position screen space equals compute screen position input. Okay, so now I'll need to compute. Now we need the clip space position. It's kind of annoying, but so in URP shader variables functions, and then pass this into the load scene depth, and hopefully that works. Okay, we got an error. Oh, I spelled that wrong. Oh, I still spelled it wrong. Okay, well. Doesn't seem to have done it, unfortunately. If I put the shader graph back on it, so that still works, but let's output the screen space position. Okay, so we can see if this is correct at least, but on first glance, it doesn't look like it. It just shows all red, but it should give us its position on the screen. Oops, I don't know why that. Oh, but you know, maybe it's in pixels. Yeah, because it's yellow right here. So, because that would mean, okay, so yellow is red and green. Everything else means that green, which is Y, is 0, but oh. Okay, this is still going on, so I should get rid of that. So why would green be 0? Because I thought 0, 0 was on the bottom and then it went up. I mean, I know that this clip space position isn't wrong because that's what the graphics card or the rendering system uses to place the actual like quad on the screen, and that's right. So Okay, so compute screen position, takes clip space. Oh, I see. It's like centered on 0 and 0, I think. Because it never adds 1/2 to it. Is that right? Oh, it does. It adds that there. Oh, I also don't normalize the clips or the green position, which might be a problem there. I guess I gotta get all 4 components and then position green space divided by equal, divided equals position screen space dot w, and then here I just pass the x and y. Oh, yeah, let me just that. Okay, well, you can see it's kind of turning to 0 there. It must be. Is it in pixel space? So it's like it's turning yellow at the very bottom, which means that it's green is positive, and then green changes to 0. So maybe 1 1 is here, but then yeah, it's red. I think red is going away right here. It's hard to see. Must be in. It must be in like pixels, which is not what we need. So technically, I mean, that's what this is, isn't it? The normalized device coordinates. Yeah, because it. Okay, so this is a reciprocal function. So yeah, it's just dividing it by the w, and then remapping the x and y from -1 to 1 to 0 to 1, which is exactly what we need. Oh, I'm so confused by why this isn't working. So okay. This is the same thing here, but with the. Okay, so yeah, this is what I was expecting the other thing to look like. Okay, so at least, I mean, this looks like it's working, but obviously it doesn't sample the depth correctly. Oh, well, I already had it right here. Because it doesn't show anything. Maybe load scene depth doesn't work in the fragment shader. I guess that could be. I'm going to be a little annoyed if that's the problem, but. Okay, let's do this. Was that really it? Okay. Well, I mean, we learned a lot about various coordinate systems. Okay, so that's kind of annoying, but whatever. So it seems like, yeah, you can't use the load function from a fragment shader, but it's just Unity just doesn't even tell you there's anything wrong. Anyway, I probably should have known that, but okay, so now at least we've got depth. So, okay, I feel good about that. Now, let's see. Maybe try uncomment this and see what happens. Okay. I mean, I think it's working. I don't see any checkerboards, but it's like replicating the depth exactly. Let's see, flip 4. I'm just gonna make sure that like the alpha's not going down for some reason, because that could be. Oh, there we go. Okay. So, okay, I do apologize because the last 45 minutes has basically been just because I use load texture instead of sample texture 2D, which is kind of annoying because in the compute shader we're gonna have to use the load version. So I mean, cross your fingers that that actually works, but okay, well, at least I guess. Oh yeah, and I've got to leave now. But I guess we're ending on a happy note. We got the checkerboard to work right. And yeah, if I move these things around, you can see it does get the correct depth for them. So I should be able to port this back into the falling pixel shader and it will. The effect is really cool. Oh, thanks guys. NTT and seclusion. Yeah, it does look cool. And yeah, it does feel good to get it working after tonight, that's for sure. So yeah, I'm glad to end on a happy note at least. And yeah, so next time I'll port this back to the pedal shader. And the only thing that I'm a little worried about is, yeah, the sample scene depth, but we have the world position of the pedal. So technically this should all be fine because we have all the data we need. But anyway. All right. Well, thanks everybody for coming by and watching. Kind of well, it was a little strange stream for me because of so many bugs, but yeah, we did figure it out. So thanks for sticking with me through it all. And I'll be back Wednesday at the same time, 9 Eastern. And I think we'll probably work on a different project because I've got to do some preparation for my video this week. So we might work on that. But otherwise, we'll probably return to this pedals. Well, I'm glad that it was interesting. Yeah, I never know. I mean, people always tell me that they don't mind to see me like debugging and like researching and stuff like that, but I don't know, it feels strange to do it on stream, but if everybody's okay with it, I guess I just need to realize that. But anyway, so yeah, thanks again everybody for coming by, and I'll see you Wednesday. That's true. All programming is debugging. That is true. Can't really cut it out. Yeah, I just need to realize that. But yeah, thanks again everybody for coming by, and I'll see you tomorrow or Wednesday. Bye-bye.